start. Okay, yeah, thanks everyone for attending. We have two talks in the recorded portion of the meetup. So the first speaker is Craig Condit. Craig works at Cloudera. He's a committer and PBMC member of YuniKorn. So he's going to present two features that one is already available. That's some improvements regarding the automation controller, and also an upcoming feature that's really exciting that allows YuniKorn to be deployed as a plugin to the default scheduler. So instead of hearing me talk, I'll give it over to Craig. You can start.
All right. Is everybody able to see the presentation?
Yes.
Okay, great. So welcome everybody. It's good to be here. I see we've got a few more folks, I think, than maybe the last meetup, so that's good. So briefly, I'm just going to talk about a few different things today. First one being some upcoming or some changes that were just released as part of the most recent YuniKorn release, which is 0.12.2, and a big new feature coming in 1.0. So just kind of a brief overview here as we look at kind of where things stand in terms of the current and future releases of YuniKorn. Our currently just released version a couple weeks ago is 0.12.2, and kind of the big user visible feature there is that we actually now support compatibility with Kubernetes versions from 1.19 all the way up to 1.23, which is all of the available versions at the moment. Additionally, we also do have the admission controller refactoring and split work that was done, which I'll go into a little more detail in a bit. And then, of course, we've got 1.0, which is a huge milestone coming up in the next couple of months. And that's going to update our Kubernetes dependency probably even a little bit further. I don't know yet whether we'll beat 1.24 out the gate or not, but we'll see what happens. But it's also going to have a new way of running YuniKorn, which is as a plugin to the Kubernetes scheduler framework as opposed to the standalone version that we use today. So we'll talk about that in more detail as well. So the admission controller improvements in 0.12.2 are basically two big JIRAs. The first one is YuniKorn 928, where which is not really user visible, but it's more kind of a refactoring and restructuring of the code. Makes it much more consistent, has a lot better error handling. The other one that's actually a little bit more visible, externally at least, is YuniKorn 941, which splits the admission controller up into a separate deployment from the way it works today. So the prior way this worked was when the scheduler started up, it actually created a deployment in the background, which launched the admission controller. This was kind of error prone, didn't always work the way you expect, and caused some problems when you're trying to upgrade the cluster because Helm would try to take the scheduler down. It wouldn't necessarily notice that the admission controller was still there and could cause some issues upgrading there. So in the new framework, we actually deploy the admission controller as a first-class citizen in Helm. It has its own deployment now. And this makes upgrades much more smooth. Additionally, we avoided one of the major sources of problems with configuring the mission controller, which is that there was a lot of backend scripting that had to happen to manage certificates and keep webhooks up to date that never quite worked exactly right either. So now the admission controller actually self-manages its own certificates and updates webhook configurations automatically within Kubernetes to ensure that the controller is active and working. So again, I want to talk a little bit about the Kubernetes version support. Like I said, we're going to be going from 1.19 to 1.23. That's the widest version we've ever supported in a YuniKorn release. Typically, it's only been about 3 releases. Part of that is due to our build dependency moving forward from Kubernetes 1.16 all the way to 1.20. This brought some new APIs and removed some existing beta and unsupported APIs, which allow us to support a wider range because we now have access to everything that we need. In 1.0, we'll likely move that all the way up to 1.24, assuming 1.24 is shipped by the time 1.0 comes out. We may or may not move our build dependency up a little bit further. There's some pretty big changes involved in that, so it's a little bit up in the air yet about whether that'll happen before 1.0 or not. Fortunately, our build dependency doesn't really impact too much what versions of Kubernetes we can support on the wire, so that isn't as big of a challenge as it sounds. And finally, the kind of the thrust of the talk is the new scheduler plugin implementation that we have in Kubernetes, or using Kubernetes scheduler framework coming in 1.0. it's probably good to talk a little bit about how this differs from the way YuniKorn is deployed today. So in a traditional YuniKorn deployment, you have both the default scheduler and YuniKorn running side by side in a cluster. And this works, but some workloads are appropriate to work with YuniKorn, specifically things that require the queuing support that YuniKorn has. Typically your batch workloads, other things are not. For example, you don't really want to have a daemon set pod that launches a critical file system on all of your pods to be, or on all of your nodes to be managed by YuniKorn. You can get into interesting chicken and egg problems where your cluster won't start up properly if YuniKorn is handling those sorts of things. You have your choice of whether or not to use the admission controller. So you can either explicitly mark a pod on submission as being bound for YuniKorn, or you can let the admission controller do this automatically for you. One of the challenges here for us internally is that this causes a duplication of effort. YuniKorn is essentially a complete ground up reimplementation of the Kubernetes scheduler. So there's lots of kind of background plumbing tasks like binding the pod to a node and mounting file systems and that sort of thing that actually have to happen within the scheduler code base. And we end up with a duplication of effort because we have both the default scheduler and YuniKorn doing these things at the same time. Under the plugin model, we actually embed the Kubernetes scheduler framework into the YuniKorn process itself. And what this means is that the scheduling logic is all handled by the default Kubernetes scheduling code. It's still in a separate process from the default scheduler, but it handles all the basic core logic, which means we don't need to worry about the plumbing. Instead, there's a set of well-defined plugin extension points where the framework actually will call out to YuniKorn to help make decisions about what pods to schedule and where. The preferred mode of deployment here is that basically everything goes to the admission controller and gets directed to YuniKorn because YuniKorn essentially absorbs the capabilities of the default scheduler in this mode. So there's really no reason to send workloads to both. Again, the one exception to this might be if you've got some sort of critical pod that, maybe things that are running in kube system, for example, you maybe don't necessarily want to run those with YuniKorn because they might be necessary to get YuniKorn up and running in the first place. Obviously, YuniKorn can't schedule itself because it's a secondary scheduler. But the nice thing about this in terms of management of the code is it's much easier to move to newer Kubernetes releases because the scheduling framework actually handles all the backend plumbing for us. We don't have to worry about, okay, Kubernetes changed the specific method in which a particular pod has to get bound. So now we have to make sure YuniKorn accommodates that in where Kubernetes releases, that sort of thing. So just kind of a graph of how things work in the various modes. This sort of depicts what happens when you have a traditional YuniKorn deployment without an admission controller. You can see we have some pods where we actually explicitly tag them with scheduler name YuniKorn that gets sent to YuniKorn. We have others that don't, and those end up getting sent to the default scheduler. It's important to note here that we're opting into YuniKorn explicitly, and our schedulers are now competing for resources. So we can very easily end up in a situation where both schedulers are trying to schedule things on the same nodes at the same time. This isn't really recommended. It works most of the time, but there are sometimes some issues. Specifically, the default scheduler is not necessarily aware sometimes that other things are scheduling pods as well. So this kind of shows how this changes if you add the admission controller into the mix. And in this case, most of your pods are going to go to the admission controller and get tagged with scheduler name YuniKorn, which pushes them to the YuniKorn scheduler instead of the default one. This tends to work a little bit better because now you're basically not using the default scheduler to do scheduling. The downside of this is that there are some workloads that YuniKorn might not be optimal for. For example, you don't really want to put there's certain types of workloads you don't want to put into a queue. The way YuniKorn handles this today is essentially anything that isn't explicitly have an application ID associated with it will get placed into a auto-generated application within each namespace. This does work, but it's, again, for some workloads, it's not optimal, especially mixed workload clusters. This could be a little bit of an issue. So the newest mode is with the plugin mode. You can see here, we still have the default scheduler in the mix, but it's grayed out. And if you notice, the YuniKorn box has gotten a little more complicated. It almost looks as though we have a copy of the default scheduler within YuniKorn, and that's pretty close to true. So in this mode, we can actually send everything with very few exceptions through the admission controller and into YuniKorn. And for the workloads where we don't have an application ID assigned, we simply deactivate YuniKorn for those pods and allow the default scheduling logic that's sitting in the same process to do the work for us. So in essence, when the scheduling framework calls YuniKorn, YuniKorn just opts out and lets the default logic take place. So here we can see within the YuniKorn process how this actually works. We've got the scheduling framework on the one side, we've got the YuniKorn plugin on the other, and we've got three lifecycle methods that YuniKorn taps into to actually do this work. So those are pre-filter, filter, and post-bind. So pre-filter is used when the framework needs to answer the question, is this pod ready for scheduling? So it'll pass a particular pod to YuniKorn via the pre-filter method. YuniKorn will either allow that pod to proceed or not. Now in the background, YuniKorn is still running its own scheduling logic just as it always does. The difference is instead of scheduling a pod, or instead of immediately binding a pod when it's ready for scheduling, it adds it to a list and assigns it to a node preemptively in anticipation of the scheduling framework asking for that pod to be scheduled via these methods. So assuming a pod passes the pre-filter stage, it will be passed to the filter stage that is now used to answer the question, is this pod eligible for scheduling on a particular node? So again, what YuniKorn does in this case is if that pod is ready for scheduling and the node that YuniKorn has decided it should be placed on matches the one the framework is asking for, then it says, yes, go ahead. Otherwise, no, we don't want to do this yet. And finally, assuming that it passes the filter stage, the framework will go off and do its thing and actually bind the pod to the node. And it will eventually tell YuniKorn via the post-bind method, pod X has been bound to node Y. This allows us to do some cleanup and get ready and mark those resources as complete so we can move on. That's basically it. Any questions?
Yeah, thanks, Greg. Question time. Anyone has questions? Okay, cool. If we don't have questions, or feel free to ask in the chat window, or Craig can always be reached on the mailing list or on Slack. If anyone. Okay, so yeah, let's move on to the next talk. Thank you again, Craig. So the next talk will be.
Sorry, I have a question.
Oh yeah, sure.
Hey, this is Mayank. The question, why we actually need to do this? I just wanted to take a step back. Why we wanted to go to a plugin architecture for default scheduler? What it is buying for us?
Sure. So there's a couple of reasons for that. One of the biggest ones, honestly, is that the upstream Kubernetes community really sees this as the supported method moving forward for secondary schedulers within the ecosystem. It actually is when I talked about potentially moving the dependency for YuniKorn up to 1.22 in our 1.0 release, one of the big barriers to that is because we have to re-implement the scheduler from scratch, we end up having to tie into a lot of private code within Kubernetes itself, most of which changes pretty radically from one release to the next. So it makes it difficult to support versions moving forward. So long-term, it would, we're treating both models as fully supported moving forward, but there certainly are some advantages long-term if we could move to this model exclusively.
The problem with this model is you would not be as scalable as you are in the other model, right?
Well, that's not necessarily true, because one of the things that we do to help make these decisions is we opt out very, very quickly if a pod isn't ready to schedule. And we also call the underlying plugins that are used for making other decisions so that the node that we choose matches the one that would have been chosen if YuniKorn wasn't in the mix. So just like today, one of the things that we get in our current deployment by speeding things up is we actually call the predicates as part of the scheduling cycle, but we do a subset of them so that we don't do the expensive ones until we absolutely have to. We do the same thing here. So the fact that YuniKorn gets called pretty early in the scheduling cycle in the pre-filter phase allows us to bail out of scheduling a pod pretty quickly if we're not ready to do it, which means we avoid most of those expensive lookups.
Did we do any performance benchmarking in these two models, that which one is better? We
haven't yet. That definitely will be coming as we get a little bit more maturity in it. We're kind of treating this as sort of a beta in 1.0. The other big reason this is important is there just are certain things that, like, it's very, very bad to have two schedulers actually actively scheduling things at the same time in a Kubernetes cluster. They're really not designed to be concurrent. And because YuniKorn is so tied into doing things in a queue basis, there are some workloads where that isn't necessarily appropriate, or where absolute compatibility with the default scheduler is required, most commonly in mixed workload clusters. And so for those cases, it's very, it helps build that assurance that we aren't deviating from the norms. So if you pass a workload to YuniKorn in the plugin mode where you haven't specified an application ID, behavior of the schedule is going to be completely identical to what the default scheduler would have done. We can't really make that guarantee today.
I have a couple of things to add. So for the performance, we need to do some performance testing, but I agree with Mayat. The plugin mode, has a longer, there's a longer cycle for the scheduling, and because of it has so many plugins to call, it should be more expensive than what we have today in YuniKorn. And for that, we can definitely do some benchmarking to compare. But in my opinion, I think plugin mode will be less efficient, and the performance will not as good as YuniKorn, the standard YuniKorn. So that's one thing. But I think there's a major thing upside for the plugin is that we want to build more impact in the Kubernetes community. And this is the way how we can work with the Kubernetes community, because like Craig mentioned, scheduling framework is the thing that the Kubernetes community is trying to build in order to let others to contribute on the scheduling side. So if we can have YuniKorn as a plugin, essentially we can work with the community and work with us some more use cases to them try and use YuniKorn, use this form. But I think we need to, that really depends on the use case. If you're running on large scale, Spark engine batch platform, I still think we should use that standard YuniKorn. That's more efficient, and when they have more room to optimize, and we can have better performance throughput. But for other use cases, like if you have machine learning, you do not run very big cluster, and you want to some sort of a queuing in YuniKorn, some other YuniKorn features, probably plugin mode will be a simpler solution to try. That's my thought.
So to hook into that, don't forget that when we run in a plugin mode, there's a number of things that we've got influence on. So first of all, we've got an influence on which plugins are running and what's happening. So that's one thing. Plus, by the fact that we schedule and we set a node on a container or a pod, that means that a number of the plugins will be bypassed. So even if the default scheduler will call a plugin because the node is already set, it will fall through the plugin calls. So there is, you can't just say, oh, because we've got this plugin version now, there is a major impact, because there is no straight line from a pod that is scheduled by the YuniKorn side by something that's scheduled by the default scheduler itself without any influence of YuniKorn. So it's not a one-on-one thing. So there's a different path that flows through the default scheduler for things that YuniKorn updates and impacts. So yes, there will be an impact. How big it's going to be, we don't know yet. But it's not like we are adding YuniKorn on top of the default scheduler, so we can't be faster than the default scheduler. That's not the case, because the way that we schedule things, and because we've made decisions already, we will pass through, and some of the decisions that we've made will be passed on to the default scheduler also, because we're sharing caches and things are getting updated when we run because of the way that we use the plugin and we use the framework.
We don't need to have a conclusion right now because we still need to run the performance benchmark. That's the fair comparison. So yeah, we should definitely do that, and to understand more about the performance impact, if that's worse or is better, that would be the final answer for us. But right now, I don't know.
Well, that's the first step. That's the first step. The reality is that once we have a fully supported plugin implementation running on top of the Kubernetes scheduling framework, that's not the end of the story. That there's innovations that can happen as well by working with the upstream Kubernetes community to improve the interfaces that are presented to plugins. So, for example, one of the things that having some sort of a pre-flight check that says, hey, which plugins should we run early versus late? Being able to influence those sorts of things, being able to cut down the number of pods or the number of nodes that are considered at a single time. These are all enhancements that could be made to that interface, and having a working, fully functional YuniKorn that's implemented this way gives us some leverage to help say, hey, if we had these things, we could probably improve performance by X amount.
Mm-hmm.
Yeah, some great discussions. I didn't want to interrupt, but we are almost running out of time. So I want to give sufficient time to our last speakers. So last but certainly not the least. So the last talk is going to be from Tingyao and Yuteng on their work on performance benchmarking. So this work is based on the standard mode of deployment, so not the plugin mode that we have just discussed. So both speakers are YuniKorn committers, and yeah, let's give it over to them to discuss. We cannot hear you.
Thank you.
It works now, but we cannot see your screen anymore. Okay, yeah, it works now. But we lost your voice again.
Really? Why? Hold on.
Yeah, we can hear you now, Tingyao. You can get started.
How about now?
Yeah, it works.
Yeah.
We see ourselves.
Everyone can hear me?
We can hear you, but we don't see
Okay.
the slides. We see. Okay, yeah.
That's the slide.
Okay.
Beautiful.
Okay, go ahead.
Okay. Here is Tingyao, and me and Yuteng try to present you the YuniKorn performance benchmarking. In this performance benchmarking, we just focus on the throughput of YuniKorn, and here is a agenda of the performance benchmarking. We are talking. There are few topics we are want to present. First of all, I want to introduce why we need the performance benchmarking and how to set up the environment. After we get the testing environment, I will explain how we deploy the testing and show the result. And Yuteng will present what kind of metrics we observe in this testing and those details, and finally analyze the results. First, why we need the performance benchmarking. The last report of YuniKorn 0.8 is a little bit out of date, and since YuniKorn 0.8 to 0.12, we add some new feature, also some improvement related to performance. Second, we need some precise data to compare to other schedule, just like default schedule. In our environment, we get 19 physical nodes to build Kubernetes cluster in local. In this cluster, we got 320 core CPU and almost 1000 GB memory. To simulate bigger cluster, we leverage low resource to simulate almost 4,000 hollow node in Kubernetes cluster. there are 4 steps to set up the environment. First, we need to prepare the Kubernetes cluster as the base of the environment. Then, if you want bigger scale cluster, we need to prepare the Kubernetes image and deploy it to Kubernetes. The Kubernetes part can simulate the whole node in Kubernetes cluster, so we can get the bigger scale cluster in Kubernetes. After the base environment is finished, we also need some tool to observe the metrics of YuniKorn. We need to launch Prometheus to monitor the port which is brought by YuniKorn. Finally, we can deploy the YuniKorn with Helm chart, which can be found in our release repo. Here is the environment setup. And about the workload detail. In this performance benchmarking testing, we will deploy 50K pod in same time. There's 10 deployment, and each deployment have 5K pod. Each pod requires 10 and CPU and 10 and memory. About the queue part, during the queue in YuniKorn won't affect the schedule throughput, so we decide to deploy all workload in the same queue. And here is the super result. And between YuniKorn and default scheduler. In this result, we observe the metrics of the Kubernetes, not the YuniKorn metrics, which cover the whole process of scheduler from discover pod to pod running in node. We choose those metrics just for fairness, because we try to compare to default scheduler, and default scheduler doesn't get the same metrics to YuniKorn. After the testing, YuniKorn is 4 times faster than default scheduler in 2000 node cluster and 2.4 faster than default in 4000 node cluster. And there's one question. You might wonder why the number of pod per second is so low. The number are not so good because the hardware is not good enough. But in side-by-side comparison, makes sense because all the testing are running in the same environment and with same default configuration. So here is my part of the the deployment and the environment, and also the result. And I will stop sharing my screen and let you turn to explain the measures detail and analyze them. Thanks.
Okay, let me share my screen. Is screen okay?
Yeah, we can see it.
Okay. I will introduce some metric diagram we observe the latency. The first thing, also wrong. Okay. The scheduling latency. The scheduling diagram shows the main scheduling cycle latency, and in the YuniKorn scheduling cycle, node sorting will sort the score node first, and then we will allocate node we will allocate resource from node in tri-node step, and the next one predicate is a part in the tri-node, and it will check condition before we allocate resource from a node. Okay, first of all, the scheduling latency, YuniKorn, Prometheus diagram and about the metric is its time distribution is cumulative, and the time unit is second. So first of all, the scheduling latency in this diagram is about 10 milliseconds. The gap between the red one and green one. And oh, sorry, schedule latency is about 10 milliseconds to 100 milliseconds. And how we observe it, first of all, the first gap between the green one and the red one, there are 40,000 schedule latency in this gap. So, and the others, the 10,000 schedule latency are in the next gap. So there are 14 schedule latency are 10 milliseconds, and the others is 100 milliseconds. So the schedule latency in here is about 10 milliseconds to 100 milliseconds. Yeah. The next one, in scheduling, in YuniKorn scheduling cycle, we saw the score in no sorting first, and its latency is about 1 millisecond to 10 milliseconds, because in this diagram, half of length is half of the latency is in 1 millisecond, and the others is in 10 milliseconds. So the no sorting latency is about 1 millisecond to 10 milliseconds. So next up, when YuniKorn finish no sorting, and we will try to allocate resource from the node, and the try node step is the step to allocate resource from a node. So how is latency in here is about the green one. So here the green one is 10 milliseconds. So most of them use 10 milliseconds to finish allocate resource from a node in here, and this diagram will show it. So we want to know where which part costs so much time in try node step. So we also add some additional metrics to check it, and we found predicate in try node where it has similar time distribution as the try node. Is almost same. So predicated in try node will be the major part to use a lot of time to finish the try node, allocate the resource from a node. So according this diagram, we can sum up this, and after YuniKorn L7 implement the B3 to improve node sorting when the number of nodes increase. Node sorting is no longer the bottleneck in YuniKorn scheduling cycle. You can see here 10 times. Instead of the node sorting, try node also we can say predicate in try node become the next bottleneck in YuniKorn scheduling. So we want to figure out the bug if we optimize the predicate, and we can abandon how much times improvement in it. So we do another performance test to figure out the range between oh, by the way, the green one, this performance, we disable or enable the predicate step. The green one enable the predicate, and the other one, red one, disable it. So if we optimize the predicate, that we should can get 2 times to 3 times performance in this range. Yeah. Okay. So how YuniKorn can keep its speed so quickly. First of all, according to the diagram, we improve the YuniKorn 807 implement V3 actually improve the no sorting and make it no more the bottleneck in the YuniKorn scheduling cycle when the number of nodes increase. The next one, we in YuniKorn code we keep using a lot of non-blocking codes and so that we can make it more efficiency when scheduling. The next one, we also keep the scheduling cycle short, and we use a lot of memory calculation and non-blocking codes to keep it efficient and quickly. So this is and have any question, and thank you for listening.
Yeah, thank you. Thank you both. Any questions? All right. So if there's no further questions, we can. That's all the talks for today's meetup. Thank you everyone who stayed for this long. We are about 10 minutes over, but these are some great discussions and awesome talks. Let's continue the discussions on the Slack channel and the mailing list. We hope to make this event a recurring one that happens at least once per quarter, if not more often. And we also have this bi-weekly community sync up. The details are on the website, so you're always welcome to join that more frequent discussions to interact with the community. So yeah, that's all for today's content. Thank you so much, everyone, for attending.
Thank you for organizing the event, Charan. Thank you.
Sure.
We appreciate that.
Yes, thank you.
Yeah, thank you. Bye.
Thank you all.
Thank you.
Bye.